Welcome to day 3 of Fast Floward. Today we go back to the always useful Flow CLI to host the entire Flow environment locally. We'll get to create accounts, sign transactions, and deploy contracts. All of that with the help of the Flow Emulator, which is a tiny version of the full Flow blockchain on your computer. And that's awesome. Before we get to that, let's review day 2. So what did we learn on day 2? First, we got the Experience Flow Playground, which is an online environment that simulates the Flow blockchain. We can deploy contracts, we can send transactions, and we can execute scripts. We learned that we need to wrap our Cadence code in contracts. Also, got to execute our first Cadence script, which is a way to read data from the Flow blockchain, and send our first Cadence transactions, which is a way to read and write data to the Flow blockchain. Writing is done through the auth account object, which is provided to us in the prepare phase of the transaction, and we execute the logic of the transaction in the execute phase. There are two other phases, pre and post, to have checks on your transaction. We also create new instances of Cadence contract resource object in transactions. Then we touched on the account storage API, specifically the two methods save and link. Save is how you store objects to account storage, and link is how you create capabilities that allow you to gain access through references to those objects in account storage. References, as I mentioned, is a way to interact with resources and other types without having to copy or move these objects. We create them either by casting, using the syntax, or borrowing from a capability. For a complete Cadence language reference, please visit docs.onflow.org. Moving on to the main topic. We saw how the Flow blockchain works in practice on day 2. With Flow Playground, we were able to deploy smart contracts, run scripts, and execute transactions. It's awesome that you can do all of that in your browser. To accomplish this, Flow Playground abstracts away most of the details. With Flow Emulator, we'll get to run a lightweight version of the Flow blockchain locally. To get started, let's create our first project configuration file. So let's fire up a terminal, and the command is a simple flow init. This will create a configuration file, flow.json, in the current directory. As you can see, it's there. Its main purpose is to link up your local environment with aliases for contracts and accounts, as well as organizing your contract deployments. Let's explore some of the sections in flow.json. Starting with networks. Here is where you'll find the addresses of the main Flow blockchain environments. When you want to execute a script or send a transaction to a particular environment, just use one of the names under networks: Emulator, Testnet, or Mainnet. On your journey to becoming a dApp developer, look at these environments as a ladder you climb towards shipping a production-ready dApp. First, start with the emulator. Then, once you have a working smart contract, ship it to Testnet to start integrating with wallets and testing it with your friends. Finally, after you've exhaustively tested your dApp, ship it to the mainnet. Then you have your accounts. Here you will assign aliases to the accounts you're using in the development process. Every flow.json starts with an emulator account defined, otherwise known as a service account. You can add other accounts to simulate various scenarios that your dApp can encounter, or for contract deployment and many other purposes. While using Flow Playground, we got to interact with smart contracts by importing them from accounts using the account address. However, if you hard code an account address in your Cadence code, you will only be able to deploy that contract in the environment that has that account. This is because account addresses are not shared between the emulator and the testnet or the mainnet. To solve this, simply use import contract from a specific path to your contract file, And the Flow CLI will take care of replacing that with the appropriate account address if one is defined in flow.json, like so. So let's say we have a hello contract, and the path to it is hello/contract.cdc. Anywhere in our Cadence code that we include this contract relative to the Cadence source file, the Flow CLI will take care of replacing it with the appropriate account that is hosting that contract. We combine all of the above sections to create a mapping for contract deployment, where we go from network, account to contract. For example, let's say we're deploying something in our emulator network, and we're going to deploy it to our emulator account. And then we just list an array of contract names from this object right here. So we have only one, and we're going to use it here. So this is network, account, and contract. Now that we know how the flow.json file is constructed, we can launch our emulator. Command to do it is flow emulator start. You should be greeted with 4 info messages, with 2 of them at the end confirming the start of a gRPC and a HTTP server, indicating that you're good to go. The emulator will continue running as long as you keep the process running. You can stop it using the sigint terminal signal, Control-C. Let's restart it. The data you create while using your emulator does not persist by default. This is useful when running tests. However, if you want to, you can instruct the emulator to persist its data using the persist flag. And we want to do that, so we go ahead and stop the emulator and relaunch it with the persist flag. Okay. This will create a FlowDB folder for the emulator to store its state. Of course, you can delete the FlowDB folder to reset your state. This concludes part 1, where we did a day 2 review of what we learned. We also got to know about Flow emulator and the flow.json configuration file and how it's constructed. In part 2, we'll explore how to use our emulator by sending transactions and executing scripts.